Hello students, this video is on section 2.6, multiplying fractions. If I say the phrase 1/2 of 40, I know that gives me 20, but are we able to figure out what mathematical operation I'm using to get that? Another example might be 3/4 of 100. If I think about it, instead of saying 3/4, if I say 3/4, then I can help myself by thinking about money. 3/4 of 100, 3/4 of $1 is 75 cents, so it would be 75. If you think about that, you might be able to tell that what we're doing is multiplying those numbers. 1/2 of 40 is 1/2 times 40, which is 20. Okay? That would look like this then, 1/2 of 40, and that's 20. And 3/4 or 3/4 of 100 is 75. Okay, so you might hear that when I say the word of, we are using multiplication in that case. So of in math is a clue word for multiplying. Okay. Likewise, when we're multiplying fractions, we can think of saying 2/3 of 2/5. I'm going to illustrate this because it can be a little bit confusing. But we have 2/3 times 2/5. Okay, so I'm going to start with this piece. Just like when I said 1/2 of 40, I started with 40 and then multiplied it by 1/2. So I'm going to start with the second piece, 2/5, and illustrate what that would look like. I'm going to get as careful as I can to show 2/5. Remember, with fractions, all the pieces need to be the same size, so I'm trying to make them as close to the same size as possible. So 2/5 is 1, 2. Okay, there's 2/5. 2/3 of 2/5. Now what I'm going to do on this edge is make 2/3. And I'm going to do that side to side by breaking the pieces up and down into 3 pieces. So that looks like this. Again, those aren't exactly equal. They should be, though. And so there's thirds, and then 2/3. There's a third. And there's a third. Okay? So what I want to look at now is how many parts are there total and how many parts are overlapping. So if I count this up, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So there's 15 total pieces now. And how many of them are shaded both ways? There's one, there's one, there's one, and there's one. So there are 4 pieces that are shaded both ways for those fractions. Okay? So when I multiply those things together, when I say 2/3 of 2/5, or 2/3 times 2/5, I get 4/15. Okay? I'm going to do another example like this, and then we'll look at the pattern because it's pretty simple, actually, to multiply fractions. Okay? So we have 1/2 times 3/4. 1/2 times 3/4. And again, I'm going to start with the second piece, just like 1/2 of 40. I started with 40. So I'm going to start with 3/4. And I'm going to draw an illustration of that. Okay, 4 pieces as well as I can make them the same size. And 3 of them are shaded. 1, 2, 3. So this down here is 3/4, or illustrating 3/4. But I want to take 1/2 of that. So along the side, horizontally, I'm going to take half. So in order to split this in half horizontally, I could do that. And I'm taking one of these halves. So there we go. How many pieces total are there now that I've done this multiplication? 1, 2, 3, 4, 5, 6, 7, 8. There's 8 total pieces. We know that total number of pieces goes in the denominator. And how many are shaded from both fractions? 1, 2, 3. So I want you to look at these and see if you can figure out a pattern, because like I said, multiplication of fractions is straightforward and not very difficult. So we have 2/3 times 2/5 is 4/15. 1/2 times 3/4 is 3/8. And what I really hope that you're seeing is that what I'm doing is 2 times 2 to get 4, and 3 times 5 to get 15. So I'm going straight across. The same thing's happening here. 1 times 3 is 3. 2 times 4 is 8. Okay? Very important, but not overly difficult. We don't need common denominators, so that's kind of nice. These are a little easier than adding and subtracting. Okay, so now that you know what the pattern is and how to do these, we'll do a few examples. And we won't have to draw the diagrams anymore, which is nice because they can get a little complicated, especially if we have large numbers. But here's an example. 5/9 times 2/7. And using what we know from the illustrations, all I'm going to do is do 5 times 2 over 9 times 7. Okay? 5 times 2 is 10. 9 times 7 is 63. 5/9 times 2/7 is 10/63. Pretty straightforward. Okay? Occasionally, we might encounter some that need to be reduced at the end. 10 over 63, that doesn't need to be reduced. So we're done. But if we do come up with one that needs to be reduced, I'll show you how to do it during the process instead of at the very end, because we can end up with some really large numbers to make it hard to work with. How about 4/11 times 1/8? Okay, I'm going to go through the steps, show that this is 4 times 1 over 11 times 8. Now I'm not going to get any really large numbers here, but in order to make them smaller right away and so that I don't have to simplify at the end, I'm going to simplify now. If I have a 4 on top being multiplied and an 8 on the bottom being multiplied, I can reduce those both. And I can reduce them both by 4. So when I reduce this by 4, I get 1. When I reduce this, when I say reduce, I mean divide. When I reduce 8 by 4, I get 2. So I'm going to rewrite this, and on the top I have 1 times 1 over 11 times 2. So the answer is 1 times 1 is 1, 11 times 2 is 22. Okay? So we can reduce in the middle and not need to reduce at the end. We should always look at the end to make sure that we don't need to reduce, but we shouldn't need to if we reduce everything in the middle. It's okay if we do, but this is where it's going to be the most beneficial to us. Okay? I'll do one more like this. I'll put a few questions up and then we'll talk about mixed numbers. So if we do 5/16 times 12/25. I don't want to do 16 times 25. So hopefully something can reduce here. I have 5 times 12 over 16 times 25. The good news is several things can reduce. 5 and 25 have a common factor of 5. So I divide them both by 5. I get 1 and 5. 12 and 16 have a common factor of 4. When I divide them both by 4, for 12 I get 3, for 16 I get 4. Now this is really jumbled and I don't want to make a mistake, so I'm going to rewrite it. My 5 became a 1, my 12 became a 3, my 16 became a 4, and my 25 became a 5. So now I can see more clearly that I'm going to get 3 over 20. 3 and 20 don't have anything in common, so we can't reduce any further, and we're finished. Okay? I'm going to write 2 questions up here. I'd like for you to try them, and pause the video, come back, I'll give you the answer. So try this. 7/12 times 15 40-seconds, and try 1/8 times 2/9. Pause your video, work these out, and come back for the answer. Okay, hopefully as you multiply these and we're able to reduce, for the first one you should get 5 over 24. And for the second one you should get 1 over 36. Okay? I'll do a separate video for multiplying of mixed numbers, which is not overly difficult either. Okay?